Welcome to this instructional video on using tape diagrams to solve one-step equations or equations in general that involve subtraction. You should have already watched a video on using tape diagrams to solve addition equations, and the steps in terms of those four phases are exactly the same for subtraction equations. So let's go right into it with our first example. We have our third example here, which has the equation x minus 41 is equal to 22. And before we actually begin drawing our tape diagram, it's something we need to establish here, a certain concept. And I'm going to use a numerical expression in order to represent this idea. Let's say I have 8 and I want to subtract 2. If I have 8 minus 2 and then I decide to add 2 to that, what would that equal? If I have 8 minus 2 plus 2, that would give me a value of 8, which is exactly what I started with. Or if I had 11 minus 5 and then I added 5 to that. So we have 11 minus 5 plus 5. What would that equal? Well, 11 minus 5 is 6, plus 5 gives me 11, which is right back where I started, right back where I began. If I have 20 minus, say, 0.3, we don't even have to use whole numbers all the time. 21, excuse me, not 20, 21 minus 0.3, and then I add 0.3 to that. Well, 21 minus 0.3 would give me 20.7, and 20.7 plus 0.3 would give me 21, which again is right back where I started. So the principle that I'm trying to establish is that if you subtract a value but then turn around and add the same value that you subtracted, you will go right back to where you began, whatever value you began with. Alright, so we'll erase that and begin working on this problem. Now we want to draw a model to represent this problem, which is x minus 41 is equal to 22. So we'll start off by drawing a bar, and that bar is supposed to have a value of 22. And then we will duplicate this bar or this tape diagram, which has the exact same size as the one we already created. So we know it has a value of 22, and we will write inside of this x minus 41. So what we have just modeled here is that x minus 41 is equal to 22. Both of the bars are the exact same length, so we've modeled x minus 41 equals 22. Now, what we're going to do at this point, we are going to make a dotted line and we'll go down to our second phase where we begin modifying this model. So now let's duplicate our bar, which we know has a value of 22, so we will not need to write that back in there, at least not yet. And we'll make another bar, but we will write x minus 41 inside of this one. We know x minus 41 is our expression and is supposed to have a value of 22. Now, remember, your goal with these tape diagrams is to find the value of x, meaning if you just have one x or one bar or one rectangle that has a value of x, what would that equal? Well, what I'm going to do in this particular instance is if I have x minus 41, I am going to create another bar. I'm going to add on to this. I'm going to extend this out a little bit longer. And I'm going to have this equal 41. This will have a value of 41. Now, why 41? Well, what I'm trying to establish here is that if I have x minus 41, and then I add 41 to x minus 41, what will that equal? Think about that for a second. If I have x minus 41 and then add 41 to it, what would that equal? Well, if you recall the example problems we did prior to making this tape diagram, if you have a value and you subtract something but then turn around and add the same thing, it takes you right back to where you began. So x minus 41 plus 41 has a value of x, meaning this entire thing that I have in the grouping symbol here has a value of x. X minus 41 plus 41 is equal to x. But now if you notice, my tape diagrams are not the same length anymore. They are not the same length. So what I have to do is I have to extend the first tape diagram. And if I extended it by a value of 41, then I must extend this first tape diagram by a value of 41. And now what I have is x minus 41 plus 41. And then I have this portion of my tape diagram, which we established earlier was equal to 22. And don't necessarily worry about the size. Some of you all may be wondering, why is a value of 22 longer than this value of 41? You're just trying to represent an idea. But if you are drawing these yourself, or if you are drawing this yourself, you can draw the tape diagram so that it's more size appropriate, meaning you can make the 41 a little longer than what 22 would be. So we know what we have right here is 22 and 41 being combined, and we have x minus 41 plus 41. So this is how we modified our value to find the value of x, or this is how we modified our tape diagram to find the value of x. And now we are going to actually solve this. So let us create another tape diagram to represent this relationship, but we're going to make this slightly longer. And this first tape diagram has to have a value of 22 plus 41. Well, if you add 22 plus 41, combine that, that would equal 63. That would equal 63. And then our second tape diagram, where we had x minus 41 plus 41, again, we already established it. If you subtract a value, but then add the exact same value, you go right back to where you started. So we know x has to have a value of 63 for this equation. So we've represented our relationship. X is equal to 63, and now we're just going to check our solution. And we're going to check our solution using variable substitution. So we will take out the x in this equation of x minus 41 equals 22, and we will replace x with a value of 63. And if we do 63 minus 41, you can do it by hand, or you are permitted to use a calculator. 63 minus 41, if you evaluate that, this will have a value of 22. So our solution checks out, and we have solved our equation using a tape diagram. X will equal 63. And this has been solving equations using tape diagrams and subtraction. You are using tape diagrams to solve equations involving subtraction. This is part 1. Be sure to view part 2 for solving equations using subtraction and tape diagrams.